Dr. Christelle Not is assistant professor at the Earth Science Department and Swire Institute for Marine Science of the University of Hong Kong. As leader of the Environmental Geochemistry and also Oceanography Research Group at HKU, she is investigating the marine environment in order to understand the impact of humans on the ocean and the climate. Her research interest focuses on understanding the dynamic of both macroplastic pieces and microplastics in the coastal environment. More precisely, she is investigating how the physical parameters may affect abundance and composition of plastic found in the marine environment. She is also interested to learn how microplastic is generated from the macroplastic under natural conditions and which actions can be taken to limit these microplastic inputs into the environment. So I'd like to now invite Dr. Christelle Not to share her presentation.
Hi everybody, I hope you can hear me. I'm very happy to be here to share with you. It's a very special occasion for me. As an academic, we don't have so many opportunities to discuss with industries and professionals. So I really want to take this opportunity to really give you a quick overview of what, as an academic, as a researcher, we are looking at when we look at the plastic problem or the plastic pollution. Can you change the slide, please? Yes, thank you. So just a reminder for everybody that plastic is quite a new material. It has been first produced at the end of the 19th century, and it will be industrially produced just after the Second World War. So it's a very new material that has been developed because it's a very resistant material and easy to produce and a lot of different usage. So it had become, over the last 60, 80 years, extremely present in our daily life. And the graph here shows the million of tons of plastic that are produced through time. So if you look at the first, in the beginning of the graph in 1950, there were almost very few millions or millions, and we are more to 300 millions of tons of plastics produced. So this exponential increase have come with a price. Can you change the slide, please? And this is what we observe. So we saw plastic everywhere, and this is have two reasons. First, the first one is the difficulty to manage plastic in terms of, I would say, a proper waste management. I would call it recycling, because as it's the way or the reason we use plastic, it's very resistant. It's also very difficult to have a good waste management to deal with it. And can we change the slide, please? And these are all pictures from Hong Kong coastline. So we see, and any of you who have joined the cleanup, who have been on the seashore of Hong Kong over the last 10 years, and more particularly over the last recent years, have seen some of these pictures. So we have plastic everywhere in Hong Kong. Now, if we look a little bit more into detail of what of this plastic, next slide, please. So this is a map of a worldwide map, and they have two important information here. So it's on a cleanup that they look and record what are the type of debris that are found on the beach. So the size of the circle gives you an indication of the proportion of plastic. So the smaller size, we have approximately 80%, or less than 80% of debris that are made of plastic. The bigger circles, it's 90% of more of the debris found on the beach were plastic. When we, and you can have the proportion, okay. So when you dig a little bit more into detail about the plastic, let me go back to this one first. Yes, let's keep it there, please. So if we look a little bit of the proportion of what different type of debris are there, when we classify them by their usage, what we observe, it's in almost all the places, at least half of them are related to food. So when we say related to food, and it's what we will go to the next slide, a little bit more in detail, what we talk or what we incorporate in food, it's mostly plastic bottle, cap, lid, plate, utensil, so plastic utensil, food wrappers, for example, and straw stirrers. So straw stirrers. So you can see in all the items that are related, or all the plastic debris that we found on the beach, a lot of them are related to food. But this is what the research have found, and we have looked at the temporal trend, and it's quite consistent over the last 10 years. We don't see a very good or positive change, and the food-related items are still the most abundant item or debris found on the beach. But these plastic debris are also have several impacts into the environment when we find them on the beach. So can we move to the next one? The first one, it's they will interact and affect the fauna, the marine fauna. So like the first picture of the plastic bag around seabirds, but we also see the turtles with the straw. They have a lot of examples of several whales, and when we look at their stomach content, they are full of plastic bags. This is definitely an important impact of the plastic debris. They have another impact that is linked to the aesthetic value of the coastline, and the picture in the center show you what a mangrove area looks like, and obviously the fact to see all of this plastic is not appealing. And then they have a third impact that we have that is probably less known, but it's the one that we have the more of the academic research work on. It's what we call the microplastic, because these big plastic pieces, this plastic debris on the sea, and mostly on the beach or on the rocky shore, they will be affected by the sun, by the wave dynamic, by the wind, and they will fragmentate. So they will break in small plastic pieces that we call the microplastic. By definition, the microplastic of plastic pieces smaller than 5 millimeters. So just, I wanted to give you a clear example. So if we look at a straw and we try to imagine, can you move the slide to the next one, please? Yes, thank you. And you need to imagine how much microplastic pieces. So in a straw, we will have 160 microplastic pieces of 5 by 5 millimeter, if we assume that it's separate in the regular shape. And it will give more than 4,000 microplastic pieces of 1 by 1. So one straw will lead to thousands of microplastic pieces. I added another example, another item, which is a small styrofoam bowl or cup. And this styrofoam bowl will give, by the fragmentation process under natural environment, under the sun, under the wind, under the rain, everything that's happening in the environment will create this fragmentation process. And it will give between 800 to 20,000 microplastic pieces. So this is a very important impact of all the plastic debris that we see on the shore, in the environment in general. And why more of the research have focused on the microplastic? Can we get to the next slide, please? Because they are very difficult to remove. We can pick up a plastic bag or a cup or a straw, but we can't pick the thousands of pieces that come from the fragmentation of the straw. What is it's much more difficult. They have some research now to try to collect them, but we are far to find a solution to the removal of this microplastic from the environment. These small plastic pieces are also obviously more easily available to be ingested by a lot of marine life. So here it's an examples of different, so the center show what all the, or not all, but it's one samples from Hong Kong. So all of these species were in Hong Kong waters. And we test and we look at some organisms in Hong Kong. So the crabs, for example, we found that all the crabs that we look at least one piece of microplastic in their stomach. We look at fish in Hong Kong, and we said that there are few studies on fish in Hong Kong now, and all of them have quite a systematic results of at least half of the fish that are collected in Hong Kong waters have microplastic in their stomach. They have also studied in clams in Hong Kong where also they have ingested. So as we saw for the big plastic pieces, they can impact the big organisms, but the microplastic can impact even the smaller. And we have research done around the world that show that even plankton can ingest some of the microplastic. We don't have research in Hong Kong on blue mussel, but this is another example that these have been done in the South China coastline, and blue mussels, as a lot of the seafood that we may consume, have ingested some microplastic. And the next question is, so what is the consequences? So the consequences for the organisms, that research has shown that the marine life that have ingested microplastic will be less resistant to other factors or other pollutants by having the microplastic in them. What are the consequences? Another consequence is what is the link that these small plastic pieces play a role or are impacted by all the other pollutants. So they will play as a carrier. So we have examples, even in Hong Kong, that microplastic pieces have heavy metal around them. So now if we think that the fauna, the fish, eat or have microplastic in them, they also have heavy metal on top of the water, the one that are present in the water, they are the one that are present or comes with the microplastic. This is also true for organic pollutants like POPs, like PCBs. I'm sure you have heard of this pollutant that come also from the plastic into the food. So these are the potential impact of the microplastic. The next question is how it impacts humans. And to be honest, there are very little research so far done on humans and also on the marine life. We are really at the early stage to understand, okay, what are the link between, or not the link, but the full consequences of microplastic and heavy metals and persistent organic pollutants. So it's very the beginning of the academic research on the impact of these small microplastic pieces. And I will just finish with one final word. It's all of these microplastic pieces come from the big plastic pieces. They all come from the daily item that we use. So, and it's the reason I'm very happy to be here, as we try to reduce reducing the use of plastic item. It's critical because it will, obviously, we will see less of this item in the environment, but we will also really try to limit the fragmentation and the input of this microplastic. Thank you. Happy to have questions.
Thank you, Christelle, for your presentation. Very insightful. I'd like to encourage, if there are any questions, we have one here so far. So we're going to respond to 2-3 questions, and we're going to go into the panel discussion. Hello, Christelle. The plastic debris maps are very impressive. How do you collect data from debris collection around the world? Are there international standards for classifying, measuring, recording, analyzing plastic debris to enable coordinated research on this topic?
So all the data are coming from a global program, Coastal Watch. But the thing is, through time and through location, the items that are recorded, like in any monitoring, are not exactly the same. So we had to do some work about selecting only and regrouping the different items that fit in the different categories. So we had to do some reworking or regrouping of different items to fit the category that we have decided, because not all the cleanup work have done with the same format of the categorization.
Thank you, Christelle. Any other questions from the audience? We can still take 1 or 2 before we start the panel, and I'd like to ask the panelists in the meantime to get ready for your introductions. So I have actually one question, perhaps, which is, I think, I'm not sure you mentioned it actually, because I've been fiddling here with all the different monitors and screens that I have to manage and chat groups. But what is the composition when it comes to the plastic that you find in Hong Kong? Does it really come from like other places, or is it from Hong Kong? Do you have any data on that?
So it's very difficult, especially if we focus on microplastic. For the microplastic, it's a key question. What is the source of this microplastic? We know that they are the big one, but exactly, it's very difficult to trace the small plastic pieces to the big plastic pieces. The way to do that is to know the polymer. So it gives us an indication, but it's not perfect. So we won't be able to say these small plastic pieces come from these food wrappers. We will be able to say these small plastic pieces come from a PET, for example, object. So the study of microplastic has its limitation about linking it to the source. And it's the reason they have more and more studies to look at this fragmentation process, because to be honest, we know very little about how fast it's happening in the environment. And we know that UV is an important factor. We know that also the microbial community that are around are also important, but we don't have rates. And this change also by the type of plastic you are looking at. So it's very difficult to know where they come from. For the big plastic, then you look at the debris, then you need to look at brands that can give you an indication. But again, it's not perfect. Brand can give an ideas, but and I think Dana from Plastic Pussy can talk more about that, but it's not a perfect solution either. So it's very difficult to know where they come from exactly.
Right. Thank you so much for your response. We've got one interesting question here that is from Stanley from Ming-Fi. With the growing use of biodegradable additives in the retail sector, for instance, plastic bags that are biodegradable, we're going to talk about it shortly in the panel. How much impact do you forecast this will pose, and whether or not the government should ban use of these biodegradable additives, or you're actually in favor of them?
In fact, as we know very little about how plastic, regular plastic, I will call them, are degrading in the environment, we know even less on the biodegradable plastic, how they will react in natural conditions. Most of the studies that are done on this biodegradable plastic are done in the lab setting. So with control UV, control pressure, but it's not what is happening in the environment. So we have few studies on that. And definitely, I won't answer for the government, but I know that they are looking at it, and they are looking at, can we have a better knowledge of how they behave before to make a decision.